think it's going to work. Okay, so back here where we were talking about strings. All right, we can't see the screen. Yeah, cool. All right, talking about strings, and every string has an index associated with each piece of it. So if I ask for index 0, I will get out that H. And so let me show that to you. So first of all, it will print that string if I ask it to right now. If I compile and I run it with this keyboard up here now. Strings, that shows strings. So it's going to print the whole thing, but I can also get those pieces of it. I can say, all right, I'd like S at index 0, S at index 1. Those guys. Then I get just the H and just the E. That's pretty nice, all right? That syntax also lets me change it. I can access and modify stuff, which is really cool, all right? So let me show that to you now. So access and modify. Let's change capital hello to lowercase hello. If I say S at 0, I can put that on the left side of an assignment because that's something I can set into. Set into the 0th index the character for H. Okay? And now I'll see out whatever S is. Does that make sense? So now if I compile and run this, hoo-hoo, I got lowercase hello out of the deal. I like that. Yeah? And so I think that is what I wanted to tell you there. I think we're ready for a question for you. If only everything broke when we were on this instead. But here is my question for you. Please go to that written ice page. I think I've made it work this time. I'll clear it out for us first, though. Moment of truth. Whee! And get into your little groups. Say hi to the people next to you. And let's say we put this string, call it S2, with these exact characters. I have it. Let's say we have it. And then, how would you, using that string S2, in this style, like I've shown you here, how would you print out, let's see, how would you print out A, B, C, D in that order? See if you can write the code and submit it. I'll give you a few minutes to try that. But yeah, feel free to code it up if you'd like. And that's where we're going. Ah, okay. Yeah, show me which ones so that I know which ones. See if there's like a key somewhere to unlock the edge of that or something. I'll figure it out. Did I press record? I hope I did. Why does my F24 work? That worries me. Third time. I'm going to take another minute or so, type it out, see what you can say. But it's going to involve which index, right? Which indices, because you got to pick out the A, pick out the B. Do you remember the order? All right, let's see what we're thinking. Nice. I think we're agreeing on the indices. There is something I do want to show you, though. If I wanted A, B, C, D in that order, all next to each other, I don't want the end-else, do I? So that's something we'll have to get rid of. So here's that idea. So first we got to figure out these indices. Like this is index 0. It always starts at 0. Index 1 is the A, 2, 3, 4, 5, and 6. So I want to say something like this. C out S2 at 1. That's going to be my first one. And we can do this on multiple lines. That's fine. And I'll do all that. And then the next one I output is index 6, right? And if I don't put endels, they'll all be next to each other. It'll just be one long word. See that? They won't be separated. I do the same thing with index 2, because that's where the C is, right? And the D is at index 0. Remember that it starts at 0. Okay. So if you want them all to be next to each other, you don't want to separate them. Any questions about this question? All right, because we're in the home stretch. A couple more things to talk about with the potentially broken keyboard. So you can use cin to read into a string, but it's only going to read one word, all right, which is a weird thing, so that's why I want to show this to you. So if you say cin into a string, it's only going to give you one word out of the deal. Let me show that to you. I want to show that to you, I guess. We can do it in this file. So if I make string s2, declare it, and now I can ask the user for something, give them a little prompt, enter a word, space, cin into s2, it's only going to get one word though, cout, and then like, here is the value of s2 with a new line. So this will look like this. So if I say hello, no, let me do something other than hello. Let's do like my name or something. So like there it is. It got it. But if I rerun the program and I type, I don't know, hi mom or something, 2 words, it only gets the first one. See that? If you want the whole thing, you have to use something different. And that different thing is called getLine. It is a function. Again, I haven't really told you what that word means yet, but we'll get there in due time. So if you want the whole line, you have to include the string library, and you use the getLine function. So you declare space for the line, give it a variable, just like we did, and then you call getLine like this, which it's kind of weird the way it's working. You say getLine, you say where you're getting the line from, the user's keyboard, and then you give the variable that will be set for you by this function and filled in with whatever we got from the keyboard, from cin. Okay, so that's the order to things, but that's how it works. In between parentheses, cin, comma, to separate things, and then the variable you're reading into. Let me show that as a file. I'll make a new file called getline.cpp. So if I want getline, I need to include the string library, and let's ask the user, that's disgusting, let's ask the user to enter an entire line. We'll take everything until the new line, until we hit enter. We'll make room for it, string line, let's call it, and we'll say getline from cin into the line variable. This gets an entire line from the user, including any white space. So like spaces and tabs and stuff, just not new lines, because that's what stops everything. Then we can print it all back out. We can say you typed colon space line and a new line. All right. Even though it's the new line that like stops it all, it doesn't actually put the new line that it read into the line variable. So if I want to break the line, I got to do it myself. We get line. So enter a line. Hello world! Exclamation point 1, 2, 3. And it got the whole thing, and it placed it into that line variable. And it's different every time. The hi mom this time. But it'll take as many things as you give it until you type enter. So it's going to get multiple things. Okay? That gives you the whole darn line. Any questions about that one? So I think I have one final example that's complicated. Are we ready for it? All right, let's do this. Let's make a program that asks the user for a lowercase word, all right? Could be any word. It could start with an A, start with a B, doesn't matter. And we are going to take that first character of that word, which is always at index 0, and we're going to capitalize it, all right? So if, for example, the user typed hello, we're going to convert that to capital hello and print that back out. If the user types ABCD, we're going to convert that to capital ABCD and print that back out. And the way we can convert from lowercase to uppercase for any character involves going back to the codes, to the ASCII table. All right, so I can't use that mouse. If you look closely, because everything's in order, like 65 is where the A starts, if we're at lowercase a and we want it to be capital A, we need to go from 97 to 65. All right? If we're at lowercase b and we need to do capital B, we need to go from 98 to 66. There's a pattern there, right? If we think of these characters as like being arranged on a number line, the distance is the same. It's like if we have lowercase a up here and we want to go to capital A down here, we need to subtract, right, from the lowercase a to get back here. There's a distance there involved. If we had instead lowercase b and we wanted to get to capital B, we again have to subtract a certain distance. But because they're in order, the distance is the same. 97 minus 65, that's 32, right? It's whatever that is the distance. And honestly, we don't even need to know it. We can calculate it because we can do math on characters. Whatever it is 32, but you could calculate it like this. What is the difference between lowercase a and capital A? That would work. That would give you back 32. See that? That's pretty cool. So that's the program. That's my cool program of the day. Let's make a new file called capitalize.cpp. And all right, we're going to ask the user for a word so we can get it with CN. All right, into a string. Enter a lowercase word. Weird things will happen if it's not a lowercase word. I encourage you to try. So we'll make room for it. We'll get it with CN into the word variable this time. And it's our job now to change word at 0, that first character, to become capitalized. All right. And no matter what that character was, we want to take it and subtract from it to capitalize it. Okay. We want to subtract a certain difference, which is the distance between the capitals and the lowercase letters, which is that lowercase a minus capital A. So you can do this. And the distance I always want to subtract is the difference between lowercase a and capital A. That's my offset. And I just want to keep on working with that. So, all right, word at 0. I would like to change you, word at 0. If you were an H, I want you to be a capital H. If you're an A, I want you to be a capital A. I want you to be whatever you were minus the distance. Yeah? That's it. And now word has changed because I've changed that first character. I can print out the whole word now with a new line. Boop. And our lowercase word, hello, capital hello. Very nice. Lowercase word ABCD, capital ABCD, and everything in between. Any questions about that? It's weird, but useful. We're making proper nouns now. So I think that was all for the lecture we get. Any questions about that last two? All right. That's where I would like to stop. Yeah, question first. What's that? Ooh, did I forget? Yeah, good job. I should have included string. Some compilers include it by default. Thank you very much. Some include it by default, but it is always the right thing to do. It could have not compiled. Yeah. I think the secret is IOStream somewhere secretly includes string for me, but you cannot bank on that. That's a great thing. So, lowercase my name, capital my name. Fun. Any other questions about this code? So yeah, please always look out for me. There's a lot more eyes in that part of the room than right here. So, yeah, that's where I want to stop for the lecture for the day. And Like I said last time, like we get that break, of course. You're allowed to go take a 10-minute break, but I think most of us would prefer that I just like zoomed through and gave you instructions for your lab so that you can take the break whenever you want, like an adult. So that's what we're going to do from now on. So if there is something new to give you, I will give it to you, and then you can just take your break whenever you want to. Walk out and come back. All right? I trust you. And we'll just be here until the end of class. But yeah, so that's what I'll do. And let me introduce to you. Obviously, because indices start at 0, everything starts at 0 in computer science. I'm going to give you your first class server lab, Lab 0. It'll be due next week, 23rd, so that's Friday. And Canvas has the due time as well. It'll be 5 for most of us, remember that. All right, but here's the Lab 0. You should be able to see on Canvas now. And there's a write-up that you'll want to read through. All right, so here's a little PDF. I'll show you part of it at least. And so here is the lab itself. And we need to get on the class server to start working on it. All right, so I'm going to log into the class server. It's my account, my test student account. And now, let me zero everything out again because I showed my other class today how to do it. Of course. Alright, so like, you're probably going to have an empty home folder where you have that one hello.cpp file. The first step after you log in is to get where you'd like to do your labs in. Maybe you want to do your labs in your home folder, that's fine. Maybe you want to make a folder for yourself called labs to separate things. That's cool too. Labs to make a labs folder. Now you can see the inside of that. But get wherever you want to do to do your lab, and then you'll scroll down, and I gave you some just blank files this time, but to get the starter code and like the whole scaffolding for the lab, you run this cute little command that I made for you. It's called gimme. It gives you some starter files, right? Gimme, and then you say the name of the lab, @ name of the class. So lab 00, gimme lab 00, please, at CSCI40. And what that did, if I do ls now, it made this new lab 00 folder for me. And I can cd in that. And we will see there exactly 3 .cpp files. And those will be the 3 parts of your lab for this first week. Okay? So the first part that you should do first is definitely the Hello World program. You're getting credit for writing a Hello World program. Okay, so that's pretty nice. So you're going to write that in the hello.cpp file. Right? You're going to change it and write your Hello World program. But you got to write more than Hello World. It should print out exactly hello, comma, space, world, exclamation point, I am ready for CSCI40, and a new line after that. All right? So that's the first part of your lab. And then you'll compile it like this and run it and watch all the beautiful stuff happen. I'll do most of that for you right now. Right? So just give you a heads up and a head start. It'll be in the recording if you're not following along right now. But I'll use Nano. Definitely do the Vim tutor, remember. Do that Vim tutor so you can use Vim instead. But right now, until you do that, you have to use Nano. And so I'm going to edit the hello.cpp file, which already exists, but it's blank. All right? So I'm going to write pretty much the Hello World program for you right now. So you can just follow along on this video or right now and get it working, or just like look at the code from class last time. Int main, curly braces, return 0. Is there a question about the lab right now? Yes, if you haven't learned Vim yet. So hello world. So I'm going to forget the full thing. All right, I'll just do hello world right now. It's really supposed to be all of this text. All right, so I'm going to get a 0 on this because of that, but I want to show you how it works. So there's most of the program. You'll have to include more. And so now to save and quit in Nano, it's Control X. Do I want to save? Y for yes. Do I want to call it the current file name? Yes. Enter. And now I've edited hello.cpp, and it has actual code in it now. ++ command, hello, -o, hello, and if there are no errors, we are in business, and I can / that hello executable, and oh man, do I have a running program. Cool. So that's pretty much the first part of your lab. You're welcome. Are we good with that? So you're going to edit that hello.cpp file, Make a hello world program that says exactly this. All right. After that, you got 2 more programs to write. The next program is cute. You're going to edit a cat.cpp file, and you're going to print exactly this to the terminal screen. So when it runs, it should look exactly like this. It's a cute little cat character. All right. It's going to involve escape codes, because to type a backslash, remember, you have to type 2. So you'll be coming back to that or the slide to figure that out. I do want to say right now, there's no spaces. There's no space here and there's no space here. Right? It's just immediately the new line after the last real character. That's that. And so that's the program that you're going to write in the cat.cpp file. Does that make enough sense? Second part of your lab. And then the final part of your lab is probably the most involved. You're going to write a program that does some math. All right? You're going to write a program that gets the average of 3 numbers. So again, this is how your program is going to work. Again, I gave you this file to start. It is blank right now, though. You're going to fill it in with everything. All right? So your program will get 3 integers from the user. All right? You'll give these prompts exactly like this. We need to see that exact output. So you'll give this prompt, colon space, and then it's the user typing on these lines. Like, I typed 7, I typed 10, I typed 15. You don't print those things, of course. The user typing and pressing enter. Because you need to give numbers. Like you could have typed 8 and hit enter. But the prompt in your program is the everything colon space, everything colon space. Then the user types after that, hits enter. And then your job is to write a 4th line, print out that 4th line with the average of those numbers. Just use integer division. All right, don't worry about double division. Just do integer division for this one. Keep it easy on ourselves. Okay. So your job is to output these prompts, and it's the user through CN is typing in like the 7 and pressing enter. All right. So your output needs to look exactly like this. You're gonna get those 3 numbers, hopefully into like 3 int variables, and then do some integer division on them to get that final output line. Okay. And again, compile like this. Run it in the way you know how. Try it with more numbers than just this for sure, but that's a good one to make sure it matches for starters. Any questions about this program? All right, so once you've got them all ready, or like it's the deadline, you want to get some sort of credit, you're going to submit your code to a beautiful auto grader that I've worked very hard on. Okay, so it's wonderful. Here's how you use it. There's going to be a command called turnin that you'll use. It's essentially this line. You're going to run this line on the terminal in the folder where all these files exist. So you're going to say turnin, name of the lab, at name of the class, and then you'll space separate all the files you want to turn in. All right, so these 3. Those are the ones you're turning in this time. So you're going to say turnin lab00 at CSCI40, and you give all your files that you worked on, hello.cpp, cat.cpp, and average.cpp, and then you hit enter. And then, in theory, the grading should start soon. Let me know if there's any errors that it ever tells you, but you'll see that it started the grading. And so this is nice. Like you'll get a grade, you'll get some instant feedback. You're welcome. And then it finishes grading. It tries to upload the grade to the class website. It should succeed in theory. And then it's like auto grading is done. Press Control-C to get back out to the terminal. Control-C. Right? So it just graded that submission. And the best place to go and look at your grade is on the class website. All right? So if I log in as my test student on the class website, give me a second. There's this lab grades link. And there will only be one for you because you're in only one class right now. But you'll see lab 00 at CSCI4. You'll click it. And then here in a nice pretty place is your grade for the lab. Obviously, I just gave myself a 0 because I messed up on everything. So this is a great time for the display to stop working. This room is haunted already. You can do it. You can do it, little guy. So close. So close. No? Okay, we're back. So you see how for the first part, it's like you got a 0, and then it says here's why. So this is super nice, color-coded, all right? Your output's on the left. The output that was expected is on the right. Except for these minus and plus signs, what those mean is like if you removed this line and you added this line, it would have been correct. But you can see how helpful this is, right? It's highlighting exactly what you missed. You missed the space, all of that stuff, and then it would have been correct. You see that? So definitely go and check your grade on the class website when you can. And then the rest, like they didn't even have a main function. It's like it didn't compile. So that's why it got a 0 there. But do you see how useful that is? Pretty cool. So I worked hard on that. If like you're in a rush for some reason, I've also made a terminal command for you to see your grades, but you should always use the class website instead. Please use the class website instead. I'll show you this right now if you ever want to use it. But the color-coded highlighting like keeps you from having to stare at it in text form all day long. So if you do view grades, it'll give you a bunch of options for which grade you want to look at. It should always be the most recent one for you probably, so option 0. Hit 0, enter. And then you can move around with the arrow keys to look at your grade. And I guess you can kind of read what's going on here, but like for the CAT program where there might be space issues, the terminal cannot show you the spaces where they should have been or weren't supposed to be. So definitely look at it on the class website. But there's another way now. You can move around with the arrows and type Q when you're done looking, and it'll get you back to the terminal. Okay, so that's how you look at your grade. And you can submit as much as you want until the due date, right? Until you get it right. The second you submit after the due date, of course, then you get the penalty. But yeah, your last submission is the one that counts for your grade. Okay, so make sure to always keep submitting all the files. Don't like submit one, get credit for just that one, submit another, get credit for just that one. It's always the last submission that becomes your grade. Okay, and yeah, just make sure to always check your grade because you might have missed a space and it will give you a 0. That's like the give and take of the auto grader. Okay, it's very precise. Any questions about any of that? Yes.
Does the grader grade on how we get the output, or does it only grade on the output?
More or less, it only grades on the output. Eventually, it'll start giving input as well, and so it'll get a bit more complicated. But this first set of assignments is only for output. Yeah. I guess technically that average one. It's going to test a bunch of different numbers, for example. So it is grading on how it looks, though. That you got the right answer for each input test. Yeah. Other questions? All right, and then everything's worth the same amount. Each file is worth the same amount of credit. And I think that is all that I wanted to say. So this is how class is going to work from now on. I'll usually give you a lab on the Thursday. On like Tuesday, you'll still have time to work. So after lecture is over, I'll either introduce a lab or let you keep working on the current one that's already out. And yeah, from now on, the time is yours. The rest of the time is all yours to work and ask questions. And